So today in this video we discuss about synchronous motor. So as a DC generator can be run as a DC motor, in the same manner an alternator may operate as a motor So, as an alternator may operate as a motor by connecting its armature winding to a three-phase supply. It is then called synchronous motor, and it is run as a speed that is synchronous speed. So, in that case, synchronous speed ns equals to 120 f by p. So this is synchronous speed. Synchronous speed ns. So here f is the supply frequency and p is the number of pole. So in case of synchronous motor, the frequency is constant. So the speed of the rotation of is therefore tied to the frequency of the source. Since the frequency is fixed, here the frequency is fixed, the motor speed says constant irrespective of the load or over voltage of three-phase supply. However, synchronous motor are not used so much because they run at a constant speed, but because they possess other unique electrical properties. So in this chapter we will discuss the work and characteristics of the synchronous motor. So first we discuss the construction. Basically, a synchronous machine is a machine that operate at synchronous speed. And converts electrical energy into mechanical energy. It is the nature of the motor. So a synchronous machine is a machine that operates at synchronous speed and converts electrical energy to the mechanical energy. It is generally an alternator, works like a motor. So like an alternator, and synchronous motor has the two main parts, that is the stator and rotor. So first, stator. A stator which houses three-phase armature winding in the slots of a stator core, and its main function is receive power from a three-phase supply. So in this figure we can see that this is the stator and these are the rotor, and this is a salient pole rotor. And as we can see that the three-phase power is supplied to the stator stator core. Now we discuss about rotor. So rotor that has a set of salient poles excited by DC. So it is also excited by the direct current from alternate N and S poles. The exciting coils are connected in series to two slip rings, and DC is fed into the winding from an external exciter mounted on the rotor shaft. So rotor basically that has a set of salient pole, as we can see that these are our salient pole, and it is excited by a DC current from an alternate N and S poles, and the excited coils are connecting in series to two slip rings, and a DC current is fed to the winding from an external exciter mounted on the rotor shaft. We will discuss better in the operating principle. So thank you.